Very good morning, my dear students. Last class, we have completed up to heat and temperature with a proper activity. Today, let me explain about flow of heat. We can compare with the water flow. Heat flow, we can compare with the water flow, students. How? Let me explain. Water flows when there is a difference in the levels of water in different places. Yes, definitely, of course. Water flow, if there is a high and low difference, water flow will be there in high to low height difference. Water flows when there is a difference in the levels of water in different places. It does not matter if there is more water in one place or another. Water from a puddle can flow into a reservoir or the other way around. The temperature of an object is like the water level. It determines the direction in which heat will flow. Heat energy flows from higher temperature to lower temperature. Next one is thermal contact. Consider two bodies, which is A and B. Let the temperature of A be higher than that of B. On bringing bodies A and B in contact, heat will flow from hot body A to the cold body B. Heat will continue to flow till both the bodies attain the same temperature. Next one is thermal equilibrium. Two objects are said to be in thermal contact if they can exchange heat energy. What is it, students? Two objects are said to be in thermal contact if they can exchange heat energy. When the heat will be exchanged, which I told you now only, if there is a heat difference, that is, if there is a heat difference, there will be the heat flow. There will be heat exchange between the object. Thermal equilibrium. Thermal equilibrium exists when two objects in thermal contact no longer affect each other's temperature, students. For example, if a pot of milk from the refrigerator is set on the kitchen table, the two objects are in thermal contact. After a contained period, their temperature are the same and they are said to be in thermal equilibrium, students. Next one is expansion in solids. Expansion in solids. Sam is trying to open a tight jar, but he cannot open it. He asks his uncle to help. His uncle says that pour some hot water on the lid of the jar. Sam does so and tries to open it now. Yes, exactly, the jar is opened easily. Do you have such experience, students? Look at the picture clearly, students. If we can't open the bottle top of the cap, we can try this too. Next one is, let me give a definition for the expansion, students. The expansion of a substance on heating is called the thermal expansion of that substance. What is it, students? Expansion in sense, you know well. The expansion of a substance on heating is called thermal expansion of that substance. Do you know one thing? Thermal in sense, what is it? Which mean heat only. Thermal mean heat only. Thermal expansion or else heat and expansion, both are same, students. Basically, thermal expansion can be classified into two, but here you are going to study two types of expansion. One is a linear expansion and another one is cubical expansion. We have one more expansion also, which is aerial expansion or else superficial expansion. You will study in higher classes. So what is it? Linear expansion. A solid has a definite shape that you know well. So when a solid is heated, it expands in all directions. That is in length, area and volume. All increase on heating. The expansion in length is called a linear expansion, and the expansion in volume is called cubical expansion. What is it, students? Look at the picture, students. First one is, it shows that linear expansion. Second picture shows that cubical expansion. Listen the picture once again, students. Linear expansion, initially before heat the object, there is no changes in the length. Okay, after applying heat, the length of the object get increased slightly. That is called linear expansion. Likewise, when you heat the cubical object, the expansion will be very even. The cube size will get expand, students. This is called cubical expansion. I hope you are all understood, students. Thank you.